Welcome. In this video, we're going to talk about zeros. So we should already know what the term zeros means. Essentially, a zero is just the points where a function is crossing the x-axis. So zeros represent where the x-intercepts would occur on the graph. Now, by definition, a zero occurs where the function is equal to zero, or rather, y equals zero, which is again relating back to the x-intercepts, because when you cross that x-axis, that is where your y values would be equal to zero. So if you're asked to find the zeros of a function, all that means is take f of x and let that equal 0. So I would say 0 equals x squared minus 7x minus 30. So now I have taken this quadratic function and I've turned it into an equation. We want to solve this equation for x. Now, this is factorable because when we look at negative 30 and we try to come up with factors of negative 30, we can develop two factors of negative 30 which sum to equal negative 7. So we've got negative 30 and negative 7, and those two factors would be negative 10 and 3. So this equation, we now have 0 equals x minus 10 x plus 3. By the zero product principle, if we are multiplying two factors that equal 0, each of those two factors themselves should equal 0. So I have x minus 10 equals 0 or x plus 3 equals 0, and each of those solves. I have x equals positive 10 and x equals negative 3. So the solutions of the related equation equal to 0 represent the zeros. Another word that is used interchangeably with zeros is the roots. So these are the roots of the function. And if we related those zeros to x-intercepts on the graph, my x-intercepts would be two ordered pairs, the ordered pair 10, 0, and the ordered pair negative 3, 0. So we have 2 points that represent the x-intercepts of this function on the graph, and they are the solutions of the related equation. So notice this was a function. This had an output of y. Remember, f of x is just a fancy way to write y. So treating this like a function, we let y be equal to 0, and the zeros represent those two x-intercepts. And if I were to graph this in my graphing calculator, I would get a graph, a parabola opening up with an x-intercept at negative 3, 0, as well as an x-intercept at 10, 0. We would also notice that we'd have a y-intercept, and this is clearly not drawn to scale, at 0, negative 30. And I pulled that negative 30 just from looking at the constant term in the given function. So this is the idea of what our graph looks like, obviously not drawn to scale. But hopefully that makes sense, and you can connect those ideas. Moving forward, we're going to start talking about more attributes of quadratic functions, and then we're going to kind of pull all of this together, rather synthesize, so it all makes sense in a holistic type context. As always, feel free to email with any comments or questions. Good luck.